Write here a structure of phenol. This is O and H. All of we know that oxygen has what? Lone pair on it. Correct?
Yes.
So what happened? These lone pairs of oxygen can be delocalized in the benzene ring. How it get delocalized and how canonical structure has been formed, that we have to check. Now, these lone pair would be utilized to form a double bond in between oxygen and carbon. And these carbon-carbon double bond would be shifted at the ortho position with negative charge. So you will get your canonical form, first canonical form in this way. This is your benzene. These bonds are stable, right? Oxygen form a double bond in between oxygen and carbon. As lone pair is utilized, it generates the positive charge on it. Correct? And this double bond, the double bond in between this carbon and this carbon would be come and become a negative charge at the ortho position, right? Because that double bond has been delocalized at the ortho position. Now what happened? This negative charge would be utilized to form a double bond in between this your second carbon and third carbon. Okay. And double bond in between third carbon and fourth carbon would be shifted here at the para position as a negative charge. So this would be your second canonical structure. You will get what over here? Rest all things as it is, that need not to change. OH with positive charge on the head. This bond would be as it is, that is also not changed. Correct? As we know that this negative charge is utilized to form a double bond in between second carbon and third carbon. That double bond you have to draw here, right? And this third and fourth double bond is shifted as a negative charge at the para position. Clear?
Yes.
Now, in the next structure, what happens? This negative charge is utilized to form a double bond in between your fourth and fifth carbon, right? And the double bond in between fifth and sixth carbon would be delocalized again, come at the place of ortho position, the another ortho position. Correct? You will get again your canonical structure. Canonical structure is always shown by double-headed arrow. Keep it in your mind. Right, Dhananjay?
Yes.
Hello?
Yes, ma'am. Yes.
Yeah, a double-headed arrow because it can be converted in this or in that. Okay. Now, what you're gonna do? You have to draw again your structure as it is, right? As we know that this negative charge is utilized over here to form a double bond. So I'm going to draw here double bond, and the double bond in between your fifth and sixth carbon would be delocalized at the ortho position with a negative charge. So here it will be double bond OH with positive charge as it is. Now what happened? This negative charge would be utilized to form a double bond in between your sixth carbon and the first carbon, right? And this double bond in between oxygen and carbon would be again go and normalize your positive charge on the OH group. That is nothing but in this way. Okay. So double bond, your newly formed double bond, and it become OH. Now, if you see this structure first and the structure second, what changes you're able to see in this? What changes you're able to see it? Only the position of double bond is completely changed, correct? Yes? Yes or no?
Yes,
Here
ma'am.
also alternate double bonds are there. Here also alternate double bonds are there. But then the position of double bond is completely different. This is also phenol. This is also phenol, right? And in between, whatever structure we got, that are called as what? Canonical structures. What is called? Canonical structure. Okay. It is too easy to keep it in your mind. But then if you practice it well, then only you are able to write the resonating structure. Otherwise, it is very difficult. This is about what? Electrodonating species. OH is what? Electron donor. Okay.
Okay.
As I said you, another one is what? Nitrate group, and that would be what? Electron. Come on, tell me, that would be what? Electron withdrawer. It can withdraw the electron. So on a benzene here, how it is negatively charge is generated. In another structure, there would be what? It will generate a positive charge. I'll show you how. Shall I erase it?
Yes, ma'am.
Hello? Are you writing?
Yes, ma'am.
No, no? Fine. So you have done with this? Hello?
Ma'am, I took a screenshot. I will write it later.
You're still writing?
No, ma'am, I took a screenshot. I will write it later.
Okay, okay, fine. Wait. Now, I'm going to share the previous screen with you. This. Now draw only this structure in your notebook if you're writing. If you're not, then it's fine, no issue. This structure. Fine? Yes?
Yes, ma'am.
So how we are going to see the resonating structure for this scene? I'll let you know. Are you able to see the delocalization of this electron? 2 electron means what? 1 negative charge.
Yes, ma'am.
Understanding?
Yes, ma'am.
So the structure which I have explained for the phenol. Now we are going to see for what? Nitrate group. Fine?
Okay, ma'am.
Fine. Now check what it is and how we have to draw it. Fine. This would be your benzene ring. Correct?
Yes, ma'am.
Nitrogen with double bond and with single bond. So that would be the nitrate group. Correct? Yes?
Yes, ma'am.
Yeah. Now in this case, what happened? As we know that this like the oxygen, nitrogen, and this another oxygen, they are in what? Resonating structure. They are in a resonance. Correct? We have seen now earlier structure of nitrate. Yes or no? Your
Yes.
negative charge would be here. Yeah. So what happened? It can be withdraw the electron from benzene and form a negative charge on the oxygen. It can form negative charge on the oxygen. So what you will get? The canonical form in this way. This is your benzene. Your double bond would be as it is. That won't be changed. As this double bond is utilized to form nitrogen carbon double bond. Okay. Your oxygen with negative charge as this double bond has been shifted on the oxygen. And here also oxygen with negative charge. Clear?
Yes,
But
ma'am.
then as double bond has been gone and form the nitrogen carbon double bond, it will be bear a positive charge. And here also a positive charge would be generated. Isn't it?
Yes, ma'am.
Correct?
Yes, ma'am.
Yes or no? Fine. So normalize this positive charge. What happened? This double bond has been shifted over there. What you will get then? Here, double bond. Okay. With carbon nitrogen double bond. Positive charge. Here is the oxygen with negative charge. Here also oxygen with negative charge. Right? And this positive charge has been shifted at the para position from the ortho. Clear?
Yes, ma'am.
Right? Yeah.
Yes.
Now what happened? To normalize this positive charge, double bond would from here can form the bond in between your fourth and fifth carbon. So you will get another canonical structure in this way. So here double bond would be forming to the fourth and fifth carbon. Here it will generate a positive charge, correct? Double bond N with positive charge. Here is the O minus structure and here is also O minus. And to normalize this, what happened? This oxygen would form a double bond in between nitrogen and oxygen. And this nitrogen carbon double bond has been shifted in between your sixth carbon and your first carbon. Clear? So you will get another and the last canonical form for the nitrate group in this way. Double bond, single bond, double bond. Here it will be nitrogen attached with oxygen with double bond. And here will be oxygen with negative charge. Got it? So what changes you're able to see in between first and the last structure? is the first, and suppose this would be the last, or I will give a number second. Structure would be same. The benzene ring attached to the nitrate group, correct? Here also benzene ring attached to the nitrate group. Thus, only change is what? A position of double bond, right?
Yes.
Right?
Yes, ma'am.
Why position of double bond has been changed? Due to delocalization, delocalization of, come on, tell me, due to delocalization of
Electrons.
double bond, correct? Yes?
Yes, ma'am. Yes.
And this delocalization happens due to what? Resonance, right? And characteristics of all the form is same. We cannot isolate the double bond at which position. Hence, while writing, we have to write it in a hybrid form. So how we have to write in hybrid form, I'll let you know. For the phenol, for this structure, suppose this structure, hybrid form you can draw in this way. Benzene should be written in this way, because the double bond where it is present we cannot predict, and hence we have to write circle inside the hexagon, right? And here your nitrate group. For the phenol, you are going to write in same way, benzene with a circle, okay, and here it will be OH. Got it? So these are what? Resonance hybrid. Most of the time, this hybrid means this circle inside this benzene can be shown with dotted lines. Okay, instead of solid, you have to draw it with a dotted circle. Okay, so you can say it a hybrid. Clear?
Yes, ma'am.
Fine. Now, the next point. Fine. You are able to see ortho position, para position, again ortho position. Localization is happening for the negative charge complete. Clear?
Yes.
Fine. Now we are going to see the next thing. Polarity of bonds. Can check. The bond is of two polar and another would be the non-polar bond. So what is the polar bond and non-polar bond that you should understand first? So non-polar covalent bond means what? When the atom joined by the covalent bond are the same, like H2, O2 and Cl2. Means hydrogen bonded to hydrogen, then oxygen bonded to oxygen, and the chlorine bonded to chlorine. In this case, what happened? Both the atoms are similar, right? Both the atoms are similar. So they stretch the now electron, shared electron. Covalent bond is formed by the sharing of pair of electrons. Means one electron would be from this chlorine, another electron from the another chlorine. So one pair of electron would form one covalent bond. Okay. So this electron pair will be at the center. Where it will be at center. It will not be lies with any of the only. Not get attached to only one atom or get attracted toward only one atom only. It is at center of the covalent bond due to equally sharing by the both the atom, and because equal strength of both atoms. Because atoms are identical in this case. See what is given. The shared pair of electrons are equally attracted by two atoms, and thus the shared electron pair is equidistant to both of them. Right? Means the distance of this electron pair from this first chlorine should be equal to the other chlorine. Same for the hydrogen and the oxygen. But then alternatively, we can say that light exactly at the center of bonding atom. As a result, no poles are developed. There won't be any sort of positive and negative charge on. Kind of molecules are neutral. How it will be? Neutral. Okay. And hence they do not bear any sort of charge on it. And they are called as non-polar molecules. Such molecules are called as what? Non-polar molecule. Right? Apart from that, another molecule like HCl, right? Here it is given HCl, then the H2O. In this case, When covalent bond is formed between different atom or a different electronegativity, shared electron pair between the atoms get displaced toward the highly electronegative atom. For example, here is HCl. So electron pairs lies near to chlorine. It is far from the hydrogen. Though bond is formed and electrons has been shared by the both of the atom, hydrogen also contributed for the formation of bond, but then the electronegativity of the chlorine is more, so electrons are shifted towards the chlorine more as compared to hydrogen. And because of that, this chlorine will bear a minus delta charge and this hydrogen would bear a plus delta charge. There is a dipole generated or charges generated on hydrogen and chlorine, and hence it bear a dipole moment. And hence such a molecule are called as polar molecule. Such a molecules are called as what? Polar molecules. Clear? Understood, Dhananjay?
Yes, ma'am.
Fine. Okay. Now see what is given about the dipole moment. Yeah. Are you there? Fine. This is quite important part. You need to keep it in your mind. If you can take a screenshot, that would be really better. Fine. Due to polarity, dipole moments, or sorry, polar molecule are also known as a dipole molecule because it generate positive and negative charge on it, and it possesses the dipole moment, right? So dipole moment is what? It is a product of magnitude of the positive or negative charge and the distance between the charges. Correct. So dipole moment is denoted by mu, that is equal to Q into D, where Q is what? Charge on atoms and D is distance between the atom. Or distance between the charges also you can say. Q is a magnitude of charge, you can say. Magnitude of charge on the atoms into distance between the charges. And it is excess of divide, and by unit it's noted with a capital D. 1 device is equal to what? 3.33564 into 10 raised to 30 centimeter. This also you need to keep it in your mind. Please write it down somewhere in your notebook. Fine. So dipole moment is a vector quantity. Vector quantity means what it has? It has a magnitude as well as direction. Correct?
Yes.
Yes or no? What do you mean by vector quantity? Dhananjay?
Both magnitude and direction.
Yeah, it has a magnitude as well as direction. Right? So it is depicted by the small arrow with a tail on a positive center and head pointing towards the negative center. For example, here they give it the HF. Like HF, they have shown what? It's means like your arrow will start with the positive center and headed towards the center. If Cl started with a hydrogen, it will go to the Cl in this way. Correct? Understanding?
Yes, ma'am.
Clear?
Yes, ma'am.
If it be H2O, again it will go in this manner. I hope you understand.
Yes, ma'am.
Yeah?
Yes,
Is
ma'am.
there any query, anything you have not understand, please let me know. Whatever things are remain, you don't need to start the BSc part, BSc PR theory and a hybridization point. That is quite important. Do not miss it. Very, very